Dear students, today I am going to take a very important chapter, that is the solution and colligative property. This chapter having theoretical as well as numerical importance. Therefore, this chapter is very important as the purpose of NEET and JEE exam as well as for the board exam. This chapter includes basically liquid solutions, ideal solution, non-ideal solution, and the backbone part of this chapter is the colligative properties. There are four different type of colligative properties. So stay tuned. We are going to study this chapter. First, when I am talking about the solution, then what is the solution? Then solution can be classified in two categories on the basis of size of particles. What are the two categories of the solution? The first one is called as the homogeneous solution. This is called as the homogeneous solution, or you can also say it as the mixture. And the another type of solution is called as the heterogeneous solution. This is called as the heterogeneous solution. The basic difference between these both kind of solution is regarding the size of particle. Here, the size of particle is very small, that is from 10 power minus 12 meter to 10 power minus 9 meter, means 1 picometer to 1 nanometer. And here the size of particle may be from 10 power minus 9 meter to 10 power minus 4 meter. If you can see here, it is called as the homogeneous solution. Why it is called as the homogeneous solution? Because after mixing, solute and solvent substance cannot differentiated by the naked eye. Therefore, after mixing, solute and solvent cannot be differentiated by naked eye. This is. And what happens here in case of heterogeneous solution? The solvent and solute particles can be differentiated easily by naked eye. Therefore, solvent and solute can be easily differentiated by naked eye. This is the basic difference. If we are going here, what are the examples of homogeneous solution? Then sugar dissolved in the water, salt dissolved in the water. In atmospheric air, there are different type of gases like nitrogen, oxygen, CO2, ammonia, sulfur dioxide, sulfur trioxide. There are different gases. All the gases are present in the same phases, and none of the gas substance can be differentiated easily by the naked eye. In the same manner, all the L-1 are also homogeneous solution. So then if we are going here for the example, then what is the example here? Like the first example, salt or sugar in water. This is the first example. If you will see another example, then mixture of gases in air. This is the another example. Third example, all alloy are the example, and there are many examples of homogeneous solution. Now if I am talking about the heterogeneous solution, what are the example of heterogeneous solution? Then dust or smoke in air. Another example like blood, milk, protoplasm, ink, paint. These all are the examples of heterogeneous solution. Then we can say here dust or smoke in air. The second example like milk, paint, blood, all the different kind of food articles like vegetables, rice, ice cream, butter, halwa, these all are the examples of heterogeneous solution. If you will see here, heterogeneous solution can further classified in two categories. One of the category is called as the suspension. This is called as the suspension. Here, the size of particle range between 10 power minus 4 meter to 10 power minus 6 meter. And what is the example of suspension? Like dust or clay in water. And the another is colloidal solution. And here the size of colloidal particles are smaller as compared to the suspension. That is, the size may be 10 power minus 9 meter to 10 power minus 6 meter. And what are the example of colloidal solution? Milk, paint, blood, almost all the food articles. These all are the examples of colloidal solution. Now dear students, if we are talking about the solution, then in this chapter I am going to take about the homogeneous solution. Homogeneous mixture also called as the true solution. Then in this chapter we will study about the homogeneous solution, that is the true solution. What is the homogeneous solution? The important thing, what is the homogeneous solution? As the name reflects that the solution in which solvent and solid particles are present in the same phase after mixing, and they cannot be differentiated even by the naked eye. Therefore, this is called as the true solution. Then what we can say here, solvent and solute particles present in same phase after mixing and cannot be differentiated by naked eye. This is a very important part. What is the meaning of same phase? The meaning of same phase is that when salt is dissolved in the water, then after dissolving, you can't find out where is the salt. Salt and water completely mix up with each other. If we dissolve the sugar in water, after mixing the sugar, you can't find out where is the sugar. Sugar completely dissolved in the water. In the same manner, in the atmosphere, all the gases are present in the same phase and you can't differentiate any of the gas substance with each other. Understood? Now? By naked eye, this is not possible. And the very important is the condition for the homogeneous solution, that the component, that is the solvent and solute particles, should not react chemically with each other. What is the meaning of this word? The meaning of this word, when the chemical reaction between the substances occurs, then the new type of substance is formed, which is called as the product. Like when hydrogen and oxygen react, they form water. This is called as a chemical reaction. When nitrogen and hydrogen react chemically with each other, then it forms ammonia. This is the chemical reaction. So if chemical reaction going on, then this is not called as the true solution. Okay, now? So the another condition, that components, what is the meaning of components? That is the solvent and solute particles. That is the solvent and solute particles cannot or should not chemically react with each other. I am going to take a very simple example. When we dissolve sugar molecules in water, the solution having sweet taste. The taste of solution do not change it. It not becomes bitter. It not becomes salty. If it becomes bitter or salty, that means chemical reaction happened between the sugar molecules and water. So therefore, chemical reaction not occurs. Therefore, the sugar solution, when sugar dissolved in the water, that is called as the true solution. Okay, now homogeneous solution. In the same manner, when salt dissolved in the water, the solution having salty taste, not become sweet, not become bitter. Therefore, we can say it is the true solution. It is the homogeneous solution. This is a very important condition. Means should not chemically react with each other. This is the another important condition for being the true solution, homogeneous solution. Now, if you will see here, then the solution contains two components. One of the component is called as the solvent component, as I have told you already, and the another component is called as the solute component. What is the solvent component? What is the solute component? The solvent component may be exist in form of solid, may be exist in form of liquid, may be exist in form of gas. In any of the physical state, it can exist. What is the solute? Like the solvent component, the solute component may be also exist in form of solid, in form of liquid, in form of gas. In any of the physical state, it can also exist. Then what is the solvent? It is the component of solution which is present in larger amount by mass. Larger amount by mass or weight. This is called as the solvent component. Then suppose we have 1 liter water and we dissolve 10 gram, 20 gram, 50 gram, 100 gram sugar molecule in that. Then sugar molecule present in the smaller quantity, therefore sugar molecule is called as the solute. And water present in the larger quantity, therefore water is called as the solvent. But suppose we have 100 kg of sugar and 100 kg sugar want to dissolve in 1 liter water, then what happen here? Because sugar molecule present in the larger quantity, therefore sugar molecule is called as the solvent. And water molecules are called as the solute because it is present in the smaller quantity. In the same manner, if you will see in the atmosphere, what happened? 78 to 80% nitrogen and rest of the another gases like oxygen 16%, CO2 0.03% and inert gases like helium, neon, argon, krypton, xenon also present. Other gases like sulfur dioxide, sulfur trioxide, ammonia, these all are present. Then nitrogen because present in the larger amount, therefore nitrogen is referred as the solvent. And another gaseous component present in the atmosphere, they are called as the solute. The another example that in gold, some amount of copper are mixed to make the hardness, to maintain the hardness of gold. Because gold is present in the larger amount, therefore gold is called as the solvent and copper is present in the smaller amount. Therefore copper is called as the solute. I think you all have better understood. And now, what is the solute? Then you can see here, the solute is the component which is present in smaller amount by mass or weight. This is called as the solute. Now, one of the important thing, if suppose the solvent component is liquid or gas, then it should be measured in terms of volume. Like we take 1 liter water, 2 liter water, 500 liter water, okay na? And here same, if the solid component is present in the liquid or gas, then it should be taken in terms of volume. Then why we are taking here, why we are writing here mass or weight? It is because of mass and weight both are standard. In the chemistry, I want to clarify that mass and weight both are the same thing. In term of physics, both are different thing. But in term of chemistry, mass or weight both are the same thing. Either you say atomic mass or atomic weight. equivalent mass or equivalent weight, molecular mass or molecular weight, both are the same thing. Then why I have mentioned here mass or weight? Because it is temperature independent, do not depends on the temperature. It always remains consistent. But when we take volume, it is temperature dependent. According to the temperature, it increases or decreases. Therefore, volume is not reliable and mass is the reliable. Therefore, we have taken here by mass or weight for the liquid as well as gas substances also. Now, if you will see here, the component of true solution, that is the solvent and solute, cannot be differentiated by the naked eye and cannot be isolated by ordinary physical methods. What is the ordinary physical methods? Like hand picking, filtration, centrifugation, these all are ordinary physical methods. But they can be separated with each other by using some special methods. What is the special methods? Like evaporation, like crystallization, like distillation, fractional distillation, steam distillation. These all are the special methods. So by using the special methods, only the component of true solution, that is the solvent and solute, can be differentiated. Now another part I am going to tell you. What is the another part? Did you see here? In a solution, solvent component always present a single component. Then if you will see here, in a solution, solvent component always single component, always one, you can say. But the number of solid component may be one or more than one to infinite. So if suppose solvent is always one and only one type of solute added in it, dissolved in it, then the solution is called as the binary solution. In the same manner, solvent always present a single component, and if two different type of solutes are dissolved in it, then total how many components are present? Two solute and one solvent. Therefore, this is called as the ternary solution. In the same manner, as I told you, solvent component always present a single component, one component, and here three different type of solutes are present, then this is called as the quaternary solution. In the same manner, if four different type of solute are present in the solvent, then total five components are present in the solution. Therefore, this is called as the pentanary solution. In the same manner, if there are the five different type of solute and one solvent, then total how many components? 6. Then this is called as the hexanary solution. But no need to do so much. In our NEET JEE syllabus as well as in board syllabus, only binary solution. This is the JEE, this is the NEET syllabus, that is the class 12th syllabus. One is the question asked on the binary solution. I got it? I am giving the example. Suppose I have water, I dissolved some sugar molecules in this, then the how many is the one sugar molecule and one solvent, that is the water, then total two components, that is called the binary solution. If I added the some amount of salt, now two different type of solute, sugar and salt with water, then total three component, that is called the ternary solution. If I want to make shikanji, then you add some citric acid, lemon juice, then the how many solute? Now the total three different type of solute are added in the solvent. Now total four components are present. Therefore, this is called as the quaternary solution. If in a question it is mentioned the term solution or mixture or aqueous solution, then what happens here? The solvent component is always a water If aqueous term not mentioned, only solution or mixture is mentioned, then you the always understand in a question, in a numerical, the solvent component is water. But if there is non-aqueous solution, means solvent component is not water, then solvent component may be benzene, phenol, ethanol, carbon tetrachloride, acetone, ether, anything it may be. I think you all have properly understood these all things. Now dear students, if you will see here, the solution can be classified in three different categories. One of the solution is called as the liquid solution, the another is called as the solid solution, and the third one is called as the gaseous solution. What are the basis for the classification of these three type of solutions? One is solvent component. If solvent component is liquid, then it is called as the liquid solution. If solvent component is gas, then it is called as the gaseous solution. If solvent component is solid, then it is called as the solid solution. Then now I am going to make a table, and multiple times question in the NEET and JEE exams, also in board exam, asked from this table. So please understand carefully this table. You can see here, I am writing here type of solution. Type of solution. Now here, this is the solvent component, this is the solute component, and I will mention here example of each such solution. Now here I am writing first about the liquid solution. I am going to take here liquid solution. What is liquid solution? In liquid solution, the solvent component is always a liquid, always a liquid, a liquid. And here, the solid component may be liquid dissolved in the liquid, solid dissolved in the liquid, and gas dissolved in the liquid. In the same manner, if I am taking here gaseous solution, then what you will see here, the solvent component is always a gas, a gas, a gas, and solid component gas dissolved in the gas, liquid dissolved in the gas, and solid dissolved in the gas. Then how much? 3 and 3, 6 subtypes. If I am taking here solid solution, then what you can see here, the solvent component is always solid, the solvent component is solid, 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 and here solid component solid dissolved in the solid, liquid dissolved in the solid, and gas dissolved in the solid, like this. If you will see example, what is the example of liquid dissolved in the liquid? Then ethanol in water. If I am saying ethanol in water, then ethanol dissolved in the water, ethanol present in the smaller quantity, therefore ethanol is the solute and water is the solvent. But if my words are water in ethanol, then water is present in the smaller quantity, ethanol in larger quantity, water is solute, and ethanol is solvent. Then be careful about the wording, about the language of giving question. So then here, suppose I am writing here C2H5OH ethanol in water. This is the example. Now we are solid dissolved in the liquid. What is the example? Any salt or sugar dissolved in the water. So then we can say here sugar or salt in water. Then here gas dissolved in the liquid. You all know some amount of oxygen, nitrogen, CO2 gas, other gases are dissolved in the water. Then if I am taking the binary solution, then what we can say here, oxygen in water, this is the example. Now dear students, we are going for the gaseous solution. Gas dissolved in the gas. I am taking a very simple example, atmospheric air. In atmospheric air, nitrogen is present in abundant, means with the 78 to 80%, and rest all gases are present in the smaller quantity. If I am taking the example of binary mixture, then what you will see here, then nitrogen present in the larger quantity, it is called as the solvent, and oxygen present in smaller quantity, that is the 16% only, therefore it is called as the solute. Then here the example, oxygen with nitrogen in atmospheric air. This is the example. Now here liquid dissolved in the gas. What is the example? Liquid dissolved in the gas. Humidity in air, moisture in air. This is the best example. Then what you can see here? Humidity. You can say here moisture in air. This is the best example. Now solid dissolved in the gas. What is the example? Any of the sublimate substance. What is the sublimate substance? One of the substance which is directly converted into gaseous form from the solid, like sodium, iodine, naphthalene, camphor, anthracene. Then what happened here? Here iodine vapor in air. This is the best example. Now here about the solid solution. Solid dissolved in the solid. Then what are the example? All alloy. These all are the examples of solid solution. If we take a specific example, then copper in gold. Because gold is present in the larger amount, therefore gold behaves as the solvent. And copper comparatively in smaller amount, therefore copper behaves as the solute. Copper chemically do not react with the gold. It is not forming another metal like the silver, iron, tungsten. Therefore, it is called as the homogeneous solution. They do not chemically react with each other. And both are present in the same phases. After mixing with the copper and gold cannot be isolated, cannot be differentiated simply. Therefore, this is the example of homogeneous solution. Now here, liquid dissolved in the solid. What is the example? Liquid dissolved in the solid. There is the example, very simple example, that during the rainy season, our home salt becomes with moisture. This property is called as the deliquescence, and the such chemical substances are called as the deliquescent. Pure NaCl is not in such nature. It is due to presence of some impurities like magnesium chloride, magnesium sulfate, sodium sulfate, like these. Then we can say here humidity, that is the moisture in NaCl. And what is the another example, very common, very popular example, that is the sodium amalgam, that is the mixture of NaHg mixture, NaHg solution. This is the best example. This is called as the sodium amalgam. Because sodium is present in the larger quantity, it exists in the solid state, therefore it behaves as the solvent. And mercury also metal, but at room temperature it exists in the liquid phase. It is present in the smaller quantity, therefore it is called as the solid. In the same manner, the gas dissolved in the solid, then what you can say here, hydrogen gas on surface of platinum, palladium or nickel catalyst. When hydrogen gas comes on the surface of platinum, palladium, nickel catalyst, then actually this is the example of adsorption. This is not perfect solution. I got it? This is not perfect homogeneous solution. This is the example of adsorption. And adsorption we will study in surface chemistry. That is the part of J exam, not for the NEET exam. I got it? Now, I want to tell you some important thing. What is the important thing? Generally, in case of sodium amalgam, it is asked what is the oxidation state of sodium and mercury. Then 99.99% students make the mistake. What they understood, sodium is highly electropositive, therefore it will lose one electron. Therefore, sodium should have plus one oxidation state, and mercury will take one electron. Therefore, it have minus one oxidation state. That is completely wrong. My dear students, I want to tell you, this is the mixture. This is the solution. There is no chemical bond present between the sodium and mercury. Therefore, the oxidation state of both substances will be zero, zero oxidation number. Why? Because there is no chemical bond between the sodium and mercury. These are only mixture. They are not one compound. They are only mixture. So this is the very important concept about this. Now, dear, we will solve some important question regarding these all topic whatever I taught today. What is the question? Very simple theoretical question. Please you understand. What is the simple theoretical question? The question given here, identify solvent and solute component among following. The first question is given here. CuSO4 into 5H2O crystal. The second question is given here. CuSO4 into 5H2O solution. The third question here given, that is the brine solution. What is the meaning of brine solution? NaCl solution is called as the brine solution. Sodium chloride solution is called as the brine solution. The fourth question is given here. Equimolar mixture of ethanol plus water. The next question, that is the here given aqueous solution of ethanol. Now, what will be the solution for these all questions? Please you see here. If I am writing here about the solution answer, then here copper sulfate crystal given. Crystal is the solid form. Crystal means that is the solid form. Here we are seeing with the copper sulfate there are the 5 molecules of water. 99.99% students want make mistake because here water is present. Therefore, water is the solvent and copper sulfate is the solute. That is the totally wrong. My dear, what happened? In a solution, one of the component which retain its physical state, that is called as the solvent, and another component which lost its physical state, that is called as the solute. Then because in copper sulfate crystal, copper sulfate retain its physical state, that is the solid state, therefore copper sulfate is called as the solvent. And because water loses its physical state, what is the physical state of water? Liquid, natural state. Because it is going to lose, therefore water is called as a solute. Then what you will see here, the first CuSO4 is called as the solvent, and here water molecule is called as the solute component. Now dear, if I am saying copper sulfate solution, that is the hydrated copper sulfate, then what happened here? Because I have written here copper sulfate solution, means here water is the solvent and copper sulfate is the solid, because this mixture exists in the liquid form. Water have liquid state, it retain its physical state, and copper sulfate lost it. Then what happened? The second answer, now here copper sulfate becomes solute and water become solvent. Now here for the third question, very simple question. This is called as the brine solution. What is the meaning of brine solution? That is called as the NaCl solution. NaCl dissolved in the water. I have already told you in a question, if they are given the term of solution or mixture, then solvent component is water. Then here, water is the solvent and brine, that is the sodium chloride, this is called as the solute. In the next question, equimolar. This is very important concept. Equimolar. What is the meaning of equimolar word? Means they are present in the equal moles. If they are present in the equal moles, means having same number of moles. If same moles, then see here what will be the concept to solving this question. Equimolar. Equimolar means equal or same mole of which? Ethanol and water. Same mole of components, that is the solvent and solute component. If suppose I am taking here 1 mole ethanol and also here 1 mole water, then what you will see, 1 mole of ethanol having here molar mass 46 unified mass of 46 gram per mole, and 1 mole of water having how much here? 18 unified mass. Therefore, what you will see here, 1 mole of ethanol having 46 unified molar mass and 1 mole water having 18 unified molar mass. Therefore, because it having higher molar mass, greater molar mass, therefore it is treated, it will behave as the solvent, and the another component having same number of moles but the smaller molar mass, lower molar mass, therefore it will behave as the solute. And always please keep remember, this concept will be applied when they have equal number of moles, when they have same number of moles. Now the next concept, that is for the question number E, aqueous solution of ethanol. Here not mention equimolar. Aqueous solution of ethanol means water is present in the larger quantity and ethanol is present in the smaller quantity. Then what happened here for this question? Here water will be treated as the solvent and ethanol C2H5 will be treated as the solute. Okay. Now my dear students, I have solved the different questions asked in the NEET exam, board exam regarding to these all concepts. Okay. Wait for the next lecture. In the next lecture, I will teach you different formula based on the quantitative analysis like molarity, normality, molality, mole fraction, mass percentage, volume percentage, mole percentage, ppm, and many more formulae. And we will also study about different questions asked in the NEET and JEE exam. Then please stay tuned for the next video lecture. I will soon present my video lecture. Thank you. Bye bye.